Got your name in it? You get tired? If you need help or have any questions, come ask one of us, please. Now's the time to ask questions.
Everything, yeah. Good. Oh my goodness. Look, ladies, gentlemen. I know it's been a while since y'all been in the classroom. Alright? We're in the second quarter of the school year. Keep up with your work. Come to class, take notes. Don't just sit around looking at you with these blank stares, expecting that you don't pick up everything. If y'all haven't noticed or picked it up yet,
That's right.
it is wise to take notes. There's a lot of times you're going to be able to use your notes on the test or your quiz.
But sometimes it's really the perfect swing.
I don't know how it's wrong, bro. I don't know.
All right.
I do
Number of times
not.
it's the number of times itself, so like equals to 9. So like 2 times 2 is 4. 4 times 4 is 16. Those are square, perfect square. But sometimes they are not perfect squares. Like this. So this is just sometimes you have to break it down even further, so. 9 times,
Look,
let's find out. 6. Okay. Now, if one of them is a perfect square, we can take it out. Okay, so it's 3. Now, what's left on the one? 6, right? Can we break down 6 even more? 2 and 3, right?
she's just crazy. You guys will.
But it's not gonna matter, because it's not here to say, okay, we can just leave it as 6. So that's how you break it down. So this one, what multiply that into 88. 11, so it'll be 11, right? So can you break down 11? Prime number. What about 8? What is it? No, 4 is a perfect split. So we can take it out. So we can 2 here. And 11 times 2. 11. What's 11 times 2? 2 square roots. So your perfect squares are 4, 16, 25, 49, 64, 81, 100, 121, and 144. Okay, those are your perfect squares. Okay. Please come ask me, Bill Flinch, if you have any questions. Erwin, you understand everything? Erwin, you understand everything?
All right, question. Who needs some help with A through F? First problem. First set of questions.
So everybody knows that, well, there's one.
Thank you for your honesty. If I got one or two, that's groovy with me. It's okay to raise your hand and say you don't understand. But I guarantee you, you are not the only one. Well, Coach Lynch, how can you be so sure I'm not the only one? Because I've seen everybody great. All right. Tashawn. so, for the first one, we are looking for square root of 64. Alright, remember, when we are looking for the square root of something, alright? So actually, let me bring it back. We'll come back to that. Alright, so this is f, if I'm not mistaken. Alright, square root of x squared. Alright, what does square root tell us that we're looking for? What you say? Somebody said something. You said 2? 2 what? You're on the right track.
Forgot what I was talking
Alright. Square root, we're looking for a pair of something. We're looking for one number that we can multiply itself, alright, to get something else. So, square root of 64, we're looking for a factor of 64, alright, that we can multiply by itself to get 64. Alright, so, the square root of x squared, if we would factor out x squared, this exponent tells us that we are multiplying x by itself 2 times. Down, stand up. Alright, so square root of x squared is x times x. Alright, x is going to be the same, so this is a pair. And I can bring out, I know the square root of x squared is equal to x. Hint, hint, that's something that you want to know. Alright, I'll say it again. Hint, hint. This one is something that you need to know for the test. Alright, I'm gonna move on. I don't know how else I can say that. Alright. So, square root of 64. Alright. What we're gonna do is factor out 64. So what are some factors of 64? Two numbers we can multiply together to get 64. Who said that? 8 and what? 8 and 8. I have 8 and 8. I got a pair. I can stop right there. So I know the square root of 64 is equal to the square root of 8 times 8. I'm looking for this pair. I have a pair of 8. So I know the square root of 64 is equal to 8. You can check that by punching it into your calculator. If you do 8 times 8, what do you get? 64. So we money. Our answer will be 8. Y'all making me nervous. I don't see a lot of notes being taken. Said that you can use your notes on the test. Yes, ma'am. If you need to do that right now, go right ahead. Say again? Yes, I think that's a wise one. Alright. Let's see another one. Ooh, B is a good one. Alright. So this is what? A. This is F. Alright. Let's look at.
If you guys did not write down that, don't ask us a question.
Really?
Okay.
Alright. So B, we're looking for the square root of 88. Alright? So, when we're looking for the square root of something, first thing we're going to do is factor it out. Alright, we're going to change 88 to a couple of factors of 88. Alright, let's go over here. Let's say over here. Alright, 88. Bless you. Somebody give me 2 factors of 88. 2 numbers I can multiply together to get 88.
8 and 11.
8 and 11. Those ones I was going to pick 2. Alright. 8. Can we factor 8 out any further? How can we factor 8 out? Say again. 2 and 4. Alright. 4 times 2. Alright, can we factor 4 out any further?
That's 2.
2 times 2. Alright. Can we factor the 2's out any further? No, we can't. We know 2 is prime. I'm going to circle my 2's. Alright, can we factor out the 11? can we take any two numbers and multiply them together to get 11, aside from 1 and 11? No, because 11 is prime as well. Alright, so boom, we have our prime factors. Alright, so that means 2 times 2 times 2 times 11 gives us 88. 2 times 2 gives us 4, 4 times 2 gives us 8, 8 times 11 gives us 88. Right, see how that works? Kevin, you good? Alright, so what we're going to do is we're going to change this 88 to its factors. These prime factors that we just got. So we have 2 times 2 times 2 times 11. We know that that equals 88. Alright, once we factor this out, what are we going to look for? Pairs. Alright, we're going to find the pair. Alright, I have one pair of 2's right here. So for every pair, I can take out one of these 2's. Alright? I don't have any other pairs, right? That means this is going to equal 2 times the square root of 2 times 11. Alright? I don't want to leave 2 times 11 underneath the square root house. So what's 2 times 11? 22. 2 times the square root of 22. Alright, so B. We go from the square root of 88, we factor it out, find the pair, alright, take one pair out, well, one of the numbers of the pair out to represent the pair, alright, and then simplify. Any questions on B? Alright, we feel a little bit better about finding square roots. Yes, no, maybe. I'm good, I'm okay, not good.
Please write this example down.
Please do. Alright. Ladies and gentlemen, if you're going to ask me this question, I can only assume that you understand it or you don't care, one or the other. Alright. Anybody still copying what we have on the board? Alright. Does anybody need to see another example from that first group of 6 problems? If you would like for me to do another example, raise your hand. Mr. Lynch, can I get another example? Don't just look at me. You need another example? Yeah, another example.
Trust me, you're not the only one.
I promise you you're not. Stay on. Get it together, man. Get it together. Good? You stand up. You need, I got some push-ups on. You sure? You got any notes? Do you have all this copied down? Number 2, reduce the following fractions to lowest terms. Alright. Anybody still copying? Good. Good. Alright. So, problem number 2, which examples y'all want to see? Reducing to lowest terms. I know y'all got questions.
Ruth's got one.
Which one, Ruth? You said E, like elephant? D like dog. Woof woof. All right, D. All right, we are reducing 7 over 13. All right, so how do we reduce fractions to the lowest term? What are we looking for? Yes, it is division, but what are we looking for?
Common factor.
Common factors. All right, we are looking for common factors. So, 7. How we factor out 7? What are the factors of 7?
Common factor.
1 and 7. What else? Any other factors of 7? No. 7 is prime. What about 13? We have 1 and 13. Any others? No. 13 is also prime. So if the numerator and denominator are both prime, all right, the only common factor that they have is 1. So we'll divide each of them by 1, and it's going to remain the same. So D is already reduced. D is already reduced for us. Good question, Ruth. Thank you. I appreciate you. Any others? Who? E? Like Ezra? All right, E. All right, we have 200 over 426. All right. What is something off that we know both 200 and 426 can be divided by? A common factor that they both have. Say it.
2.
2. How do we know 2, Gabe? They both have 2. What about this last digit? What kind of numbers are they? Are they odd or even? They're even.
The last digits are even.
Right. So they're both even numbers. All right, remember, all even numbers can be divided by 2. So if nothing else fails, if I see I have something with even numbers, I know they both can be divided by 2. So I'm going to divide each of them by 2. 200 divided by 2 gives me what? 100. 426 divided by 2 gives me what? What's 4 divided by 2?
213.
2. 1 divided by 2.
13.
1. 6 divided by 2. 3. So 100 over 213. All right, now we're going to look at 100 over 213. Or 100 and 213. Do they have any factors in common? No, they don't. They only both can be divided by 1. Can they be divided by 2? 100 can, 213 cannot. They can be divided by 3. 213 can, 100 cannot. Can they be divided by 4? 100 can, 213 cannot. What about 5? 100 can, 213 cannot. 6? No, yes. 7? No, no. 8? No, no. 9? No, no. 10? Yes, no. It's now simplified. We have reduced our fraction to the lowest term. So E is 100 over 213. All right. Any others? Come on, come on. Those are 2 good examples. We can get them one more in there. Right there. Take notes. All right. Number 2, pick one that you want to see me do. A, B, C, F. Which one? The F. The F. I want to do F. I want to do F. Alright, so A, we have we have 12 over 18. Alright? Need to reduce. So, we're going to find factors for each. What are our factors for 12? What are our factors for 18? Factors for 12. 6 and 2. Alright, hold on. Y'all remember a little trick I told y'all about finding factors? Factoring out. Where we should start? Start with 1. Ask yourself. You don't really know everything we divide by 1, so start with 1. 1 times 12. I'm good. Then go to 2. 2 times what? 2 times 6. Can we do 3? 3 times what? 3 times 4. Alright, can we do any more? That's it. Once your factors that you find, once they get close to each other or the same, when we're done, because it's going to start repeating. If I go to 4, then it's 4 times 3. Can't do 5, then it's 6 times 2. You got me? Right with me? Yes, no? That confuse anybody? You get some blanks there. Alright, what about 18? You know we have 1, 18.
9 and 2.
2 and 9. How about 3?
3 and 6.
3 and 6. Can we do 4?
No.
Can we do 5? Nope, and then we're back to 6, so we money. Alright, so what is the greatest common factor that they have? 6. Boom. We have them 6. Alright, so we're going to divide both the numerator and the denominator by 6. 12 divided by 6 gives me what? Somebody, it's on the board, I'm pointing to it. 2. 18 divided by 6. 3. Bang. 2/3. I just reduced my fraction. Down. Copy. Not. Alright. We all good for the second set? Yes, no? Alright. Let's see. How much time we got?
Can I go to YouTube 5?
Yeah, you need to go ahead. Alright, so number 3. Alright. Perform the indicated operation. Anybody still copying? Alright, here we go. So, we got multiplication, we got some subtraction, we got addition, and we got division. Alright, so, alright. Y'all getting it good, so I didn't do this to be good. Alright. Adding, subtracting, multiplying, or dividing fractions. Whenever we are adding or subtracting fractions, what are we looking for? Common denominator. We need a common denominator. Alright? Alright? What about when we multiply? What are we looking for? I agree. We just multiply numerator with numerator, denominator with denominator. Two sweeping across, one sweep. I don't know, I do math, I didn't. Divide, how do we divide fractions? Say it again. Keep, change, flip. Alright, I hope we writing this stuff down. So, examples. We have 1/2 plus 5/6. Alright. Common denominator. What common denominator can we have between 2 and 6? What's the least common multiple? That's the least common, that's the greatest common, least common factor. Alright, so we know 2 can go into 6, right? Alright, so what do we have to do to this 2 to make it 6? Multiply it by 3, alright? So what we'll do is we'll multiply both the numerator and denominator by 3, alright? That's gonna change our fraction. 3 times 1 is 3, 3 times 2 is 6. Now we have 3 over 6 plus 5 over 6. Now once our denominators are the same, what do? Say it again. No, we're not multiplying. We're adding. Alright, so we're not gonna add straight across. Alright, we're only gonna add our numerators. Alright? The denominator is gonna remain the same. Think about it like pizza. Alright, how many slices are in one whole pizza? 8 slices. Doesn't matter. You can have 1 pizza or 15 pizzas. One whole pizza is always gonna be 8 slices. So I have 3 slices of a pepperoni pizza, and I have 5 slices of a sausage pizza. I want to know how many total slices of pizza I have. 3 plus 5 is 8. All right, 6 slices still make up a whole. Shamonte, you got that? You sure? All right. So 3 6 plus 5 6 is going to equal 8 6. All right. Subtracting. All right, we'll do the same deal. All right, so I have 2/3 minus 1/2. All right, I need a common denominator. What can I do to make my denominator the same? Question. Am I wasting my breath up here right now? You ready to go ahead and take the test? Because I'm not seeing anybody take no notes or nothing. I'm gonna get limited questions.
Let's just finish this problem.
Yeah, let's do that. All right, so what I can do, I'm gonna go ahead and multiply my denominators, 3 and 2. So bam. Bam, 2 times 2 gives me 4 over 6. 3 times 1 over 6. All right, now my denominator is the same. 4 minus 3 gives me 1 over 6. All right, multiply. Let's say I have 1/2 times 2/3. I'm gonna just multiply straight across. 1 times 2 gives me 2. 2 times 3 gives me 6. And I can reduce that, and it'll be 1/3. If I'm dividing fractions, let's say I have 2/3 divided by 4/5, which is question number C, 4/5. All right, keep, change, flip. Keep the first fraction, change division to multiplication, and flip the second fraction to the inverse. So I end up with 2/3 times 5/4, multiply straight across. 2 times 5 gives me 10. 3 times 4 gives me 12. I have 10 over 12, and I know I can reduce that if I divide each by 2, and that'll give me 5, 6, either of which is okay. Any other questions before we get right? All right. So, cell phones up. You can keep your, what is it, pressure view out. That's all right. All right. Once I pass out the stuff, I'm gonna pass out some calculators. You're welcome. Best of luck to you all. Also, remember the order of operations. Head march, please excuse my daughter Sally. Use parentheses first, then exponents, then you multiply, or divide, then you add, or subtract.